Hey Algebra 2, today we're going to talk about polynomials and their graphs. So we said the other day that a polynomial means many terms. So up here I have many terms. And you can see that we have some bigger exponents than what we're used to doing. And we're going to try to figure out how does changing all these exponents change your graph. I'm going to show you some things on Desmos now. So now you're viewing my Desmos graphing, and you can see that I have a quadratic pulled up here, and you know that it's quadratic because it has an exponent of 2, and that looks like a parabola. So let's see what happens if I change that exponent from a 2 to a 3. And I'm apparently going to have to change one more thing so that there we go. Let's change that to a minus. So when that was a 2, it was a parabola that looked like this. It went up to the far left and up to the far right. But when I switch the exponent to a 3, now it goes down, it comes up, it makes a turn, down makes another turn, and then it goes up to infinity to the far right. Let's see what happens if I change that to a 4. It kind of looks like the parabola did again, except that it's a lot skinnier. So it's still going up to the far left, it turns, and it goes up to the far right. All right, let's change that to a 5 and see what happens. Oh, now it kind of looks like it did when it had an exponent of 3. It's going down to infinity here, comes up, makes a turn, goes down, makes a turn, and then it goes up to infinity to the far right. And then let's change it to a 6. Well, it kind of looks like, at least it goes up to the far left and to the far right. Doesn't really look like a parabola anymore because it has kind of a weird middle. But if you kind of play around with this, you'll start to see some patterns here. When the biggest exponent is an even number, it kind of had the same shape. And then when the biggest exponent was an odd number, it had the same shape. We're going to revisit that. All right, so now we're going to get some vocabulary down for polynomials. So before we can tell what a polynomial graph is going to look like, a couple important things. It's got to be in standard form. So standard form means it goes biggest exponent to smallest. So I'm looking through here and I'm looking for my biggest exponent. So that x to the 6 is the biggest one. And when you write something in standard form, the exponents go in descending order. So I have an exponent of a 5, so that term needs to come next. Do I have an exponent of 4? Yes. Negative 8x to the 4th. And then 3 comes next. Exponent of 2, I don't have one, okay. A 10x comes next, and then the 9 comes last. So before you can start to tell what your graph looks like, it has to be in standard form, and that means your exponents go in descending order. Leading coefficient. So think about when you wanted to be the line leader when you were in kindergarten. Where was the leader at? The leader was always at the front of the line. So the leading coefficient is -4. The leading coefficient is the coefficient of your biggest exponent. And then hopefully you remember what a constant term is. The constant term is the plain old number, and it comes last. So my constant term is 9. The constant term is important. It will tell you your y-intercept. Super important there. The degree is how we name a polynomial. So degree, you name a polynomial by the biggest exponent. So in this case, we have x to the 6th is our biggest exponent, And so this doesn't have a special name. It is just called a sixth degree polynomial. End behavior. End behavior is what the graph looked like at the far left and the far right. It is the direction of the graph to the far left and far right. So as it turns out, the leading coefficient and its exponent determine the end behavior. Those two things work in conjunction, and it can give you a clue as to what your overall graph will look like. All right, so we're going to complete this chart. Let's say that I have y equals a times x to the nth power. And let's say that a is positive, and a represents your leading coefficient. So hopefully you remember from looking at Desmos, when the biggest exponent was even, it had a certain look, versus when it was odd, it had a certain look. So if your degree is even, like x to the second, x to the fourth, x to the sixth, etc., etc. All right, so we're going to match up this row and this column. We're going to assume that your leading coefficient is a positive number and your biggest exponent is an even number. So let's say we're working with 7x to the fourth. The graph will probably look something like this. It goes up to the far left and up to the far right. That is its end behavior. I say it goes up and up. The textbook will probably write it like this. This says, as x goes to infinity. So x goes to infinity means you're looking at the right-hand side of the graph. F of x, which is y, goes to where? So that means, let's see, so when I'm looking here, it's going up to positive infinity. So as x goes to infinity, f of x is also going to infinity. This says as f of x goes to negative infinity, so now we're seeing what it does on the far left-hand side. F of x, or your y value, is also going to positive infinity. I color code them now. All right, so when a is positive, so we're looking at that. And then we have the degree. So the degree, you have to remember, is your exponent. In this case is the 4. All right, so it's easiest to do this one next. So hopefully you remember what would happen if I just flipped it and I made that negative 7x to the 4th. Do you remember what changing it to a negative did to a parabola? Remember how it flipped it down? Well, it does the same thing here. So now it'd go probably something like that. So if your leading coefficient, your a, is a negative number, paired with your biggest exponent is an even number, I generally say it goes down and down. I'm trying to describe the end behavior to the far left and the far right. It's going down to infinity or down to negative infinity and down to negative infinity. All right, so let's do it the book way. As x goes to infinity, that means what does it do to the far right? Your graph is going down that means it's going to negative infinity. And then as x goes to negative infinity, that means what's happening on the far left, your graph is also going down to negative infinity. All right, and a is your leading coefficient. Let's say we have an odd degree, like maybe x to the third, x to the fifth, x to the seventh. Hopefully you remember from looking at the Desmos a minute ago, it was kind of making like an S shape. So let's say I have 14 x to the third. All right, so a is a positive number, and my biggest exponent is an odd number. Your graph will generally look something like this. And I would say that this goes down and up. So I always describe what it's doing to the far left and then to the far right. All right, let's see what the book says. As x goes to infinity, so this means what's it doing to the far right, because x goes to infinity to the far right. Your graph is going up to positive infinity. And then what happens is x goes to negative infinity. So negative infinity means what's it doing to the left side? Your graph is going down to negative infinity. And then similarly to this, so if you just kind of can memorize what this does and this one, then every time you make your leading coefficient negative, it just flips it all. So if this was, even if it was negative x to the fifth, it's going to have a similar shape, but it's going to flip. Now it's going to go up and then down. Your graph is going to look something like this. I would describe it as up and down. So your leading coefficient is a negative number, even if it's just a negative or negative 1. And then your biggest exponent is an odd number. All right, so this says as x goes to infinity, that means what's it doing on the right-hand side? Your graph is going down to negative infinity. And then over here, as x goes to negative infinity, so that means what's it doing to the far left? Your graph is going up, and it's going up to positive infinity. All right, so this is a resource that you should try to memorize, and it's super helpful in sketching your graphs. And I think we're going to pause it there and continue the notes on the next one.